Okay, so okay. The next, Newton's law of motions. Okay, first one applies to inertia. Okay, when we talk about inertia, we're talking about objects at rest. And an object stays at rest unless it is moving in a uniform velocity. If it's moving in a uniform velocity, it will continue to do so unless there's an external force acting on it. Okay. So, what are these external forces? Usually, when we talk about external forces, we're talking about resistive forces. For example, friction, okay, or air resistance. And most often than not, in most things, both of these are acting at the same time. Okay, where can we see both of them acting at the same time? We can see them on a car. Okay, a car will have, uh, excuse my poor drawing of a car. Okay, this is the car. It's going really fast. Okay, straight forward. But there will be two forces acting on it, which is most likely be the friction here and also air resistance here. Okay, there will be friction due to the force applied by the ground and also air resistance here. Air resistance, I'll just write AR. Okay. So the world isn't always so perfect. We do not have objects that always continue to do so. They don't just keep moving. There's always something going on somewhere that's stopping it or slowing it down, or even sometimes even speeding it up. Okay. That's going out of topic for this course. Okay. In this class, we're going to revise a bit on some examples of we still some of the examples of Newton's law of motion. Let's try. Okay, I'll go with you guys on the first question. Maybe bring you guys back to speed. I'm pretty sure you guys left this chapter a long time ago, so I'll try to refresh your minds. Okay, so there's two forces, 200 newtons and 150 newtons acting on an object. So that's the object here. This thing shown on the diagram below. If the mass of the object is 2 kilograms, the magnitude of acceleration of the block is okay. So they ask like this. Okay, always remember what do you need to do? You need to find F. Oh, this is a very thick heading. Okay, let me just roll that down again. So we all always have to remember F equals to ma. When this chapter comes, F equals to ma everywhere. Okay, you even don't know what's going on. Just remember F equals to ma. Okay, you just writing it down gives you something. Okay. Okay. So we write F equals to ma. So why do you write that? Because they want you to find what? The solution. Okay, and they already gave you the mass of the object. So what do you need to find? You need to find this. If you find AF, we can find A. Is it so simple? No, because there are two different forces acting on it. So how would we go about answering it? Okay. Anyone wants to give a try?
Yeah, we've got constant mass and constant velocity. Since we have constant mass, we have change in velocity.
Oh, you want to open? I think doing that might be a bad idea because the thing they asked for is a magnitude of acceleration. They want the acceleration first. If you wanted to find the change in velocity, that means you have to know if it was at rest first. But we do not know when it was at rest or when it is even moving. There's no time period here. There's only forces. So the best thing you can do in this setup is actually break it down. Break it down by the forces and find force acting on it. Okay. So I would do this. Okay, example here.
Can I try?
Oh, you like to try it? Sure. Right. Yes, correct. You must know the
From
codes.
the
Mm.
so the object, the weight is downwards in between, right?
Mm-hmm. Okay, how about I draw a diagram to give you a hint?
So
catches up. Okay, I'll draw a diagram. There's two types of diagrams you can draw. One is a triangle, one is a parallelogram. I think I'm gonna draw a parallelogram for this one.
Can I do without drawing the diagram?
If you're really good and you have a lot of experience in this, yes, you do not need the diagram. But even myself, I take
Yes, I don't know if I draw the parallelogram. I don't know where's the object.
the object is always here because this is where the forces are going. 150 by 200.
Mm,
Okay, so there's one that's going 150 here, and there's one going there's this 10 now. Okay, so it should be okay. They made the calculation quite simple because let's go straight. There's this 10 here, this 10 here, so you can just bisect this and you get it back here again. Okay, so it's always going in the middle here. Okay, it's always going in the middle, somewhere in between the middle here. Okay, and this angle should be 180, right? So it's should be 160. Okay, so this 200, this should be also 200. This 150, this should also be 150. Okay, so how do you go about? Okay, if you're using a parallelogram method, you can go like this. Okay, say f squared equals to 150. Okay, newtons here, squared. Okay, plus 200 squared, and then you minus. Minus what? 2, 150, 200 cos 160. Okay, then anyone tell me where does this formula come from? I think it's very familiar.
yeah, cosine rule.
Yeah, it's cosine rule. Okay, so I already gave you guys the value. Already put it neatly like this. Can you try to find
But
f
I
squared?
still don't understand why we must use this formula.
Oh, why you must use this formula? Okay, you want to know what is the total resultant force. Okay, the resultant force that's acting on here. Because when you have a 200 Newton that is acting like this, you need to know the components. Okay, you need to know the components. Since one is acting totally in the horizontal axis, while one here is acting on the, okay, it's acting to an angle to the horizontal. It's acting to an angle to the horizontal. There's two things you can do. Okay, one, you can use this cosine rule. Okay, I think this for this type of question where there's one that's totally horizontal is easier. But if you do think this is a good idea, you can actually break this down into its components. Okay, so if this is 200 newtons and you know this is 20 degrees, you can break this into cos and break it into sine. Okay, and then you can find out f squared equals to f resultant y squared plus f resultant x squared. You can also do this too, the same thing. The same thing. Okay. How about this? Okay, let's try to find this and let's see if this answer lines up. Okay. Okay. Let's see. 150 squared times 200. Okay. Minus 2 times 15 times 200. 150. Yeah, this 150. See? And 200 cos 160. Okay. Can someone calculate this? Tita, tita, tita. Anyone on your calculator? I think it should be around 118.88 0 minus something something something. Is this what you guys get? Make sure your calculator is not set to radians, it's in degrees. Okay.
Can we do it like 200 sine 20
200 sine
from
20.
the
Yeah,
Gamba asal? There.
200 sine 20. We're using cos rule, so if you want to find sine rule, I'm not sure if you
200
can.
sine, because the object is downwards, so we equal them. Cannot.
Okay, try. You get the answer.
Okay, I will do.
Okay, you will do. I think, okay, if I continue this, I will get around 344.79 newtons. Okay, and then check this. Okay, and after that, what do I do? Yes, I input this straight into here. And I get 344.79 equals to 2a. So a equals to 1.72.4. Yeah, so just 172.4. Yes. Okay. Since the questions were given mostly in 2 and 3 significant figures, I can follow 3 significant figures. So the final answer would be 1, 7. Where's the Okay. So how about the other way? Finding it f squared using this method. Okay, can also. Okay. What do we do first? We have to make a table. Okay. Let's make a table. Okay. I will label this as F1 and label this as F2. Okay, this will be the x-axis and this will be the y-axis. Okay, this will be F1 and this will be F2. Okay, so F1 does not have anything in its y component, so it'll be 0. It only has one thing on its x component, which is 150 newtons. For F2, it has two components. It has a y component, x component, and also a y component. Okay, so to find its x component, okay, so that's 200 cos 20, which is roughly cos 20. If you do not want to change these values, oh, my calculator is in radians. I told you guys, but okay. If you don't want to change these values, you can actually keep them as 200 cos 20. Okay, no problem there. Because this one, they only want to be sure the final answer. Okay. Let's take a lot of decimal places this time. 3939. Okay, 0. Okay, and you can just find the tool. Sine 20. I do sine 20, you'll get 68.404. Okay. Okay, so we have a y component and x component. Let's see if this logic here works out. Okay, f squared equals to the square root. Okay, so this will be 187.50, so that will be roughly 5 to, let's So the 237.9390 squared plus 68.
Did you plus?
Oh yeah, 337.
337.
Yes, thank you. 337 plus 68.4040 is squared. Okay, what do we get here? It 337.9390 squared plus 68.4040 squared. Think you're gonna get the same answer. 340.79. Ta-da! Afterwards. Okay, I calculated for afterwards, huh? So yeah, you can. These are the two ways you can actually calculate. If you ever forget how to do the parallelogram method, okay, let's say you forgot your home file maths somehow. I know it happens. Don't worry. If you do forget, you can always rely on these components. Always break it down to its components and then just add all the components together. Since they are all vector values, you can just add them. Okay. What I mean by vector values, they have direction. This is moving in the x-axis, this is moving in the y-axis. Don't worry, even if you go for higher level education, okay, your university level, this question will just have 3 dimensions. That's all. Okay, so when it's 3 dimensions, then one line. Okay, let's say if it's simple one, maybe I'm doing off-tension, but I'm doing. Okay. There's 3 levels here, so this will be x, this will be y, this will be z. So if there's one here going here. So if you went to this point, that means it has a z value. It's going up. It's also going to the right, and it's also going backward. You do an angle. It's also going backward. So you have to break it down into 3 components, but you still use the Pythagorean theorem. Okay, you still use these. Okay, so you still get the final answer here, 344.79. Even if you don't use this, but I recommended using this because when you use the parallelogram method, okay, you find this. The answer is faster. Use all these values together, and then you already know this much. But here, okay, let's say you're a bit slow with your calculations, or maybe you're not so you're a novice calculator user. So inputting all of this takes a bit of time. Okay, you can judge by the fact, okay, inputting one of these one by one, or just inputting this one line throws and then square rooting it. I think this would be faster. And when it comes to physics, the fastest way is always one of the best ways to calculate. And not all the time, but questions like this, yeah. This is actually objective question. I just removed the answers here. I don't want to see the answers. Because I know you guys, if I give you guys ABCD, you just start guessing answers. Okay, because you'll say, oh, I don't have enough time, I'll start guessing. Okay, this will be the same. Okay, never mind. Okay,
So we don't have to use the acceleration, the mass 2 kg.
yeah, you do. You see here. Continuation getting the force is equals to 2A. But still not equals to A. You always have to come back here. If it's dynamics, uh, even easily put, if it's question 3, 4, or 5, you cannot run from F equals to MA. Because questions 3, 4, or 5 in your objectives is always F equals to MA. Alright. Then your final answer, 172. Okay.
Okay, thank you.
Alright. Let's try. Okay, a simple pendulum is raised. Okay, let's try a second question. Okay, a simple pendulum is raised 10 cm high, as shown in the diagram here. Okay, so the delta here is 10. It is then released to oscillate with acceleration A. Okay, oscillates with acceleration A. The length of the pendulum is 1.2. Find the acceleration of the pendulum. Okay, I think you guys might have learned this before. Would you like to give it a try? This will come back in your semester 3, and when you're learning semester 3, this becomes a very easy question pull up. This will become your basic question. This is your first chapter in semester 3. Uniform oscillation, SHM.
Okay, I try.
Okay, have a try. That's I think this question will take you around 5 minutes. Okay, have a try. Okay, so this question before you attempt, you have to know the second thing about this guy, Mr. Newton. Okay, who's known for a lot of things. Okay, now the second thing is who's known for, and the picture again is second law. Second thing is known for is second law. That's right. Okay. So in the second law, okay, uh, what does it state? Okay, it says that the rate of change in momentum. Okay, so when they say rate, okay, rate of change. The moment you see this word, the moment you see this phrase, it's always talking about some type of time concept. Time starts to get involved. Okay, like just now the inertia thing, it was still not no time involved. Okay, but here time gets involved. What I mean by time gets involved, you start doing calculus. He invented calculus just for this. Okay, our calculus is always that, okay, you're doing differentiation integration there, but he did the method for us to compute values. Okay, so what does it state? Okay, the second law of motion states that says that the rate of change of momentum, okay, rate of change of momentum. Sorry, something caught my tongue. Momentum of an object is directly proportional, okay, to the resultant force. And the force acting on it. Okay. So when this thing comes along, okay, this is where you start to have a lot of formulas now. Okay. So F, okay, the force is equal to the rate of change in momentum. What is momentum? mv. Momentum is the product of a mass and its velocity. Or you can say it's rate of change in displacement. Okay, you can keep talking in riddles like that, or you can just say moment product of its mass and velocity. So okay. Cool. So you will have you can expand it like this. You'll have n dv over dt plus dm dt. Okay. Then finally you'll get m dv dt. Okay, why m dv dt? Okay, why I usually say m dv dt is because most conditions the mass doesn't change. Okay, what I mean by mass doesn't change. If mass doesn't change, it's zero, right? Okay, mass doesn't change means when a car is going on a highway again, okay, same car, okay, boom, boom, okay, same car going on a highway again, very fast. The change in its mass, okay, yes, there is a change in mass. It's always a change in mass, okay. Whenever there's combustion, there's change in mass. Okay, for car, maybe a car is a bad idea. Ping pong ball is a better idea. Okay, ping pong ball is a better idea when it comes to change in velocity. The mass stays constant. You do not change the mass, but you change its velocity. Okay, so dv dt is here, but dm dt, there's no change in mass for the ping pong ball. So you just put 0. So you only take m dv dt. But for a car or a rocket ship, okay, any rocket ship. Sorry for my bad drawing. Okay, I don't know this guy gonna go to Mars or not. I don't think I'll even leave the orbit. Okay, very bad. Okay, for any rocket ship or whatnot. So for these things, there is a change in mass. Okay, so expect whenever there's a car or whenever there's a rocket or anything with combustible fuel, anything with fuel, there will be a dm dt. you will start using dv dt and also dm dt. So both of these will be taken into account. Okay, unless they state that the velocity is constant. Okay, maybe they say a car is moving at constant velocity. Okay, find the upper amount of petrol that has been used. That's when you start doing this stuff. Okay? That's where you start using breaking it down and using your knowledge on how to break it down. Okay, but usually you won't see that type of question. Not because it's not well asked or anything, but it's actually quite hard. So they actually know where to give you guys some pity marks. So something they will not ask this. But there is questions before in past year papers where they've asked before about airplanes and also about rockets. Okay, a rocket was taking off, find using DM, you have to use DMDT. Also guns, pistols. Okay, when you're getting shot, right? When a gun is shooting. Okay. So yeah, this whole class is just me drawing badly. Okay, a gun is shooting pew pew pew. Okay. Pew, pew. Well, actually, you're losing mass here. Why? Because you're finishing your bullets. So there's a change in mass also here. Okay, and this change in mass also has something to do with the recoil action. Okay, recoil is also a change in momentum. No? Okay, there's a change in momentum. As it's moving forward, it's also moving backward. So these three pistol, rocket, and car, you might see DMDT. But for example, a ping pong ball or maybe other scenarios, you will not see much of DMDT, you'll see more of DVDT. Okay. I just wanted to share that. Okay. Okay, now back to the question. Okay, Brian sent me his answers.
Sorry, can I talk?
Oh, yes, sure, sure, sure. Okay, then I broke down the components into fx and fy. Okay, but sometimes those components may not line up with the angle you are given. Okay, they might not always line up with the angle you are given. So what do you do then? Okay, what do I mean by that? Okay, so one of the scenarios is actually the pendulum. Pendulum is a perfect scenario. Okay, so you have a ball here. Oh, I made it thicker again. My apologies. Okay, three is nice. Okay, you will have mg. Okay, mg is the biggest component here, right? It's actually the biggest component. And mg, even though it looks towards, okay, it looks towards the ground. Okay, you want to say it's a vertical component. But in this scenario, there's actually, you have to break it down into two here. Okay, you have mg that is sine. Okay, mg that is sine to this angle, sine theta. And when you're asking where does this angle come from, it's coming from here again. Okay, sine theta and also mg cos theta. Okay, mg cos theta. Okay, why do we need to break it down into two? Okay, we want to break it down into two because we want to find the angle. Okay, how do you find the angle? Okay, so you can use this thing first. Okay, what I give you is 1.2. Okay, and here they said that if this is the total length of the okay, they said that this is the total length. Okay, total length of the pendulum is actually 1.2. Okay, move up by 10 cm. So this is actually 1.1. Okay, I think you have 1.2, you have 1.1. What is this? Sin cos or tan? So ka or to? Is this ka? Cos equals to adjacent over hypotenuse. Okay, can you guys quickly find this thing? How much is this? Okay, cos theta equals to 1.1 over 1.2. How much is theta? Theta on your calculator, please.
23.56.
23.56. Okay, the 3 by 5 is equal to 6.
6.
All right, good. Okay, so what do you want to find? We want to find this component, the sine component. Okay, because it wants to say a pendulum is really shown, then it's really oscillate. Find the acceleration. Okay, okay, A. With acceleration A. Okay, so acceleration A is like this. So always like this. All right. Okay, for sem 1, they are only asking at this point. But in sem 3, uh, there's something called standard harmonics. Harmonics is when something is oscillating repeatedly. Okay, where do you get this line? Okay, imagine this is also again going off tangent a bit. Okay, imagine this thing but in a 2D plane. Okay, you imagine this like looking forward, looking from here. Okay, you're not looking at the side, you're looking from here. You see this ball go up, go down, go up, go up, go down, go up, go down, go up, go down, go up over time. And if you plot this over time, you have SHM, standard harmonic motion. And this is just any oscillating motion. You learn the general formula on how to plot this. Okay. Maybe it's a bit irrelevant of telling now, but I just want to see you guys expert. I assume you guys already contacted your seniors and already bought all your 72, 73 textbooks. Yeah, then you might see this word a lot there. I also have my own notes. I'll share those notes when you guys come to Sem 3, full notes of Sem 3 and Sem 2. Okay, okay. After they ready, okay. So now we know theta 23.56. Okay, now let's try to find A. Okay, so we know that F equals to MA. F equals to MA again. Cannot run away. F equals to MA means mg sine theta equals to MA. A gone, A gone. So it's actually always A is just G sine theta. A is just G sine theta. A equals to G sine theta. Okay, how much is G? 9.81. 9.81 times by sine of how much is this? 23.56. Okay. Can someone put that on the calculator? Can tell me how much it is?
It's 3.92 or 3.9.
3.92. What's behind here?
No, you want the 3.921.
3.921. Okay, 3.921 and 3.92 lah. Okay, okay, okay. 3.92. Okay, is negative 2. Okay, here did they give you guys 2 or 1? Okay, give it 2. Okay, both is all, everything is 2. So you should also probably answer in 2. So then, yeah, 3.9 lah. Okay, that's good. 3.9. Okay, now let's look at Brian's working. Okay, Brian's working. Okay, G sine 25.53. Okay, cut a lot of working here. But it's actually you use tangent to find the theta. Okay, no problem also. Use a Pythagoras sum. Okay, from C. A bit unnecessary because actually, like I mentioned just now, any two lines you can use any of the same constant. Okay, you can use any of the same constant. So just having 2 is already enough. Okay, you don't have to go to tangent. Okay, too far already. Just use cos and you would have gotten save some time already on that. But okay, good job. You went the creative route. You still find the same answer. Okay, G sine 23.3 and you get the answer. Alright. Okay, now okay, already 9:06. Okay, let's take that 5-minute break I mentioned before. Okay. Go freshen up, have your breakfast, guys. We'll continue the class around 9:12. Okay, 6 minutes now, 9:12. Zoom class. Okay, for both of your submission, let's see. Okay, let's read out the question first. Force P pushes a row of identical objects shown in the diagram. The mass of block X is X kg. What is the force exerted by block P on block Q? P on block Q. Okay. So when it's question like this, right? Okay. What happens is this itself becomes the force that's holding it. Okay, let's see. Okay. So how do we start here? Always remember, like I mentioned just now, we always remember f equals to and a. Always say, just write it down. Okay. You don't know what to write it down, so just write it down. Okay. So we know this is x. We know this is also x. We also know this is x. So we already have the mass. GG. See? F equals to 3xa. Okay. And we can also say f equals to 3fa, then a equals to f over 3x. Okay, can write. Okay. Okay. So what will be the resultant force E acting on each? Okay, that's actually quite straightforward. Okay, what is resultant force? Resultant force is F equals to A again. And when it comes to MA again, it's X, right? And we know A is okay, F 3x. Okay, that means what? On each, so on each will be F over 3. Okay, since there's no, they didn't mention anything about resistors or anything friction like that. So everything is just F over 3. Okay, so I can say that all of them have F over 3, means that they all share the same force, they all share the same force. Okay, they're all acting like one big body. Okay, they're all acting like one big body. Okay, when they're acting like that, then you will say, okay, F2 equals to what? F3, F over 3. And what's F1 minus F2? So equals to F over 3. Okay. Then we know that F3 is F2 is also what? F1 equals to, sorry, minus F2, F3, after 3, F3. So F3. So F3. So F1 equals to F2, 2F over 3. Okay. So on Q, okay. Maybe I can draw the diagram over here. Okay. So to draw the diagram, confirm it will be very clear for you guys. Ready? So with 3, I have the 3 objects here. Okay, be P, Q, and R. Okay. So this is pushing here. What is pushing here? F1. F1. And then there's two forces interlinked. Okay. How much F1, F1, how much F3, and how much that's not F3. Let's just talk about F1 and 2. Okay. How much whatever this is pushing on here is the same as how much it's being pushed on as well. Okay. Why is this the case? Okay. Why is this the case? Okay. We go to this guy again, Mr. The white wig. So white wig. Okay. We go to his third law. Okay. Can anyone tell me verbally what is his third law? Always changing the colors. Okay. Anyone remember what's his third law? Every action has a
Reaction force, you mean?
opposite.
Equal but opposite.
Go by opposite reaction. Okay, that is his third force. Okay. Okay. Reaction. Okay. Equal. Opposite. Reaction. Okay. So if I hit you, okay, my hand is also getting hit. Okay, I can show you that. Okay, I'm here. Okay, I slap. Okay, let's say I slap someone, right? Slap. Slap this guy here. Okay. 2 minutes. I slap this guy's hand here. When I slap his hand here, there is the hand now. Okay, robot hand. Okay. When I'm slapping his hand here, you will also say his hand is also slapping me back, right? His hand is also slapping me back. And the harder I go on his hand, the harder I hit his hand, the harder his hand will react back to me. Okay, but then why do you think some people when you hit them so hard also never hurts? That's where the mass comes to play. That's where momentum comes to play. Okay, so when a small person, it's a big fella, it's a big fella. Okay, you barely feel anything. You never feel anything. Okay, I'm a big guy. Okay, I'm a big guy. Big guy don't feel pain. But if a big guy hits back the small fella, habis lah. He don't know where he go and where he go fly already. Okay, you don't know. Okay, that's the point. Okay, because what is always conserved? What is always conserved is momentum. The momentum is always conserved. Okay, how much momentum you give, that's how much you get back. Right? Because there's a change in mass. Okay, there's a delta mass. There's a delta mass. From this guy to this guy, there's a change. Okay, they are not the same mass. So the velocity will not be the same. Okay, as a resultant, the resultant velocities will be different. Okay, that's why when this guy hits him how fast also, nothing happens. But if this guy even hits him like softly, he'll still flying away. Okay, don't know where you go. Okay. But for in this case, since all of them are the same mass, okay, all of them are the same mass, they all have the equal, okay, they are equally reacted upon. Okay, so that's why here F2 and F3 are same. F2 and F3 is same. Okay, and they also move at the same level also. Like, okay. Okay, you guys did the string technique. Okay, F1 minus F. Okay, you guys are doing something, but missed the point a bit, I think. Who went into here? Okay, not really. Like, you can ignore this part because they only ask on block Q. Okay, what is they asking? What is the force exerted by block P on block Q? You don't have to calculate the R block. See, R block is always obviously this thing, right? Okay, I don't have to calculate the R block. Only what is the force exerted by block P on block Q. So this one don't care about it first. Okay, here also you made. I think both of you guys made the same mistake. Okay, you cared about the R. No need to care about R. Okay, because they only ask the question what's force exerted by block P on block Q. They ask what's the force exerted by P and Q on R, P and R on Q are a different story. But here only ask for block P and Q. Okay. Here I told you, right? I told you one of the questions has a dm over dt. This is the question over dm over dt. Okay, let's read out the question here. Okay, this confirms subjective question. These are all objective. This is subjective. A rocket of mass. Okay, a rocket of mass 1,500 kilograms. Very large rocket, very massive rocket. Injects burnt fuel at a rate of 10 per second. Okay, what is this value? This is a okay, I'll make it small before. Okay, this is a dm over dt value. Okay, and it's a negative as well because it's decreasing in this mass. It's ejecting. Ejecting means it's decreasing. Okay, dm over dt is 8. On ignition, the fuel is injected at rocket as speed now. Okay. Fuel, okay, here this is what? This is a dv over dt value equals to 2000. Okay, find the thrust. What is thrust? Thrust is obviously force. Okay, okay, so what is force? Force equals to ma. Another way you can write is b delta m over delta t. Okay, I think it's quite straightforward. You guys can try. What is the answer for A? Just theta on your calculator. Oh wait, this is not dv or dt. My bad, my bad. It's not acceleration. This is v. This is v. This is dm dt. I think very straightforward. Can you just input the values here?
$1,600.
You missed the zero. You missed the zero. 16,000. $16,000. Okay, yeah. And it's okay if you want to give a full value like this, but they also use a 4 significant figures. If you want, you want to say 1.600 times 10 to the power of what is this? And oh wait, no, 10, sorry, 5, 10, 10. Oh wait, 4, this should be 4, right? 4. Can. No problem. Okay, no problem. You want to say this also can. Okay, 1, 2, 3, 4. Everyone just use exactly 4 figures. But like I mentioned last class, when it comes to physics, you can always plus minus 1. Plus minus 1. So you're just plussing one more significant figure here. Totally accepted. Okay. If you don't even mention this whole thing also, it's okay. Okay. Let's B. Determine the initial acceleration of the rocket. Initial acceleration. Excuse me. Okay, so what do they mean by initial acceleration? Okay, you can remember it like this. F is always a product, right? It's a scale, it's a vector product. Okay. That means that there is always some force acting on it. Okay. Okay, so in this case, the force here is up. This thrust is up. But what is pulling it down? Okay, what is always acting down on an object? Okay, if thrust is here acting up, what is acting down?
Weight.
Apa?
The weight.
Weight. Okay, what is, yes, weight. Okay, good. So what is weight? We usually tend to write weight as mg. And then that equals to
G.
ma. Okay, so you already got the answers here. Okay, this is okay, we know this is 1600 minus how much is mg? Okay, we already know the mass of the rocket, which is 1500, and then we know gravity 9.81, sorry, equals to 500. Okay, how much is A? Quickly. How much is A?
0.857.
Yes, 67. 8.8567. Okay, you can give them the 4 places because yeah, also like mentioned just now, they also give them the 4 places. MS negative 1. MS negative 2. Okay. So you see here, this is quite you might think this is quite slow, okay, 0.56767, even for such a large object to go at this speed alone. And this is already accounting after gravity, so plus gravity is going this fast, so that's actually going quite fast. Okay.
So it's very slow.
No, it's actually very fast. Okay, if you can escape the gravity, you can escape gravity's acceleration, then that means you're already going faster enough to levitate. Okay, if you can make, okay, at all times, there's gravity acting on you, right? 9.81. If you can accelerate anything more than 9.81, okay, let's say 9.82, you're already floating in the air. Okay, this is you. Okay, this is Dharani. This is Dharani. This is the ground. This is the ground. Okay, Dharani is actually flying in the ground right now. Flying away from the ground. Even this minute amount, okay, you'll be slowly going up, and your velocity will be increasing. Why? Because there's a acceleration. If acceleration, there's change in velocity. Maybe your velocity starts very slow, like 0.0000001, but it goes slowly increasing because it's square one. Okay. V equals to U plus AT. So your velocity will only increase as time increases. Okay. So you keep going there faster and faster. This is irrelevant, but this makes the class fun, so that's why I like to mention all this. Okay. If you're more than the gravitational acceleration, it is enough for you to levitate basically. So you can become a magician if you wanted to. Okay, C. Okay, C is a bit of an essay answer. Okay. because they ask explain why there's a time lapse between ignition and liftoff of the rocket. Okay. This one I would say, okay, copy my answer. Maybe you never heard on this answer before. Okay. Uh, okay. So on ignition, so on ignition, during ignition, on ignition. Okay. Okay. The thrust produced. Okay, how about I just type it out? I think me writing it down is just gonna make it more uglier. Okay, yes, I'll just write it down. Yes. Okay. During ignition. Oh, it has a nice font. I didn't know that. I will use this. Okay. Thrust produced is less than the weight of the rocket. Okay. Now, meaning that, okay, as it starts to slowly burn. Okay. Okay, starts slowly burn. Okay, it doesn't immediately go to that speed anymore. It's slowly going to that speed. Okay. So the thrust at the initial point is slow. It's like still burning properly. Okay. Then only it gets to the point where the thrust produced is more than the weight of the whole rocket. Okay. So after time, the mass of the rocket. Okay, remember here the mass is actually decreasing, reduces from the fuel combustion. Okay. So slowly, the fuel keeps burning, and that burning reaction is causes more thrust. Okay. Okay, this is rocket science. This is what we say. The joke we say. This isn't rocket science. This is literally rocket science. You have to find why we say actually rocket science is a very hard topic. Okay, I use this logic out. You need fuel to lift the weight. Fuel itself is a weight. But when you have too much weight, you need more fuel. When you have more fuel, you have more weight. So the problem is always like chicken and egg. Like more fuel, more weight, more fuel, more weight, more fuel, more weight. You you have to, the problem with these rocket scientists here, these math scientists here, okay, they have to find this perfect equilibrium where just enough fuel to burn, and after the burning process, the mass reduces so much that it can lift off. Okay, do you know almost 80% of the fuel in a rocket actually burns just before it leaves the Earth's orbit? Just before it leaves, it burns almost 80% fuel. Because after outside the Earth's orbit, you actually don't even need fuel, as you cannot even have combustion. There's no medium for you to push. In the Earth's atmosphere, you push the air beside it. Okay, you're giving a thrust, but outside there's no air. There's no medium for you. So they use a different technology lah. Okay, I'll go to that later part. Okay, yeah, I'm already going off topic already here also. Okay, I'll do the fuel combustion. The rocket lifts off when thrust. Oh, I should probably go down. Thrust is more than weight. Oh, okay. Okay, let me just see if I can edit this. Okay. I could just write it like this. Okay, during ignition, during ignition, thrust produced is less than the weight of the rocket. After time, the mass of the rocket reduces from the fuel combustion. The rocket lifts off when the thrust is more or greater than the weight of rocket. Okay, you should be good. Okay. Actually, yeah, I was thinking just now, right? So when you actually go to outer space, you use less of the fuel. Basically you can use light. Okay, when light has a momentum, right? I think you learned that later in science. Light has momentum. Okay, so using that concept itself, you can actually move things. Let me show you I'll just show you a video. Okay, I'll pause the recording now. Just show you guys something. Okay, maybe I can show you guys during the class as well. Let me just try to find that thing. One second. Okay.
Okay, today I'm going to be seeing if light can push. So I'm going to be trying to use my 32,000 lumen flashlight and also my 5,000 milliwatt laser to see if I can push things with light. So in order to push something, you have to impart a force on it. For example, if I want to push my hand, I have to put a force on it. As long as I put a force on it, I can move it. So for example, to move this tape, I mean in order to have
So
the
okay.
lighter. Why isn't it increasing the scale here? For my friend to attempt thin wire hanging transfer it, it's completely still now. You can see it's not turning one way or the other. Let's see if I shine the light on it, it can perturb it and start it swinging any direction. 3, 2, 1.
It goes slightly, you see that? It moves
Whoa, it moved it. Okay, so and site that teaches
slightly.
you how to
So
think like
this is actually how our what do you call that, satellites, very fast space satellites, what we use our very fast space satellites, this is how we do it. Okay, from just the proportion of light itself hitting the plates, that's how it's moving, just ever so slightly, because it's in a vacuum in outer space. You're in a vacuum in outer space, you're moving very more than you think. Okay, even small, minute acceleration is enough to give you some speed. Okay, can remember object stays in motion unless something external is acting on it. Yeah, so imagine that there's nothing acting on it. There's no resistive forces. There is but on the atomic scale, okay, atomic, like one or two atoms straight somewhere here at the, okay, that scale in outer space, you have almost nothing, and so even minute amounts of velocity or acceleration from even just light hitting you is enough for you to even move like big giant satellites. Okay, okay, I think I went off tangent a bit. Okay, but just some extra knowledge for you guys. Just teach you something. Okay. Now we come to an essay question. I think this is a typical paper one section C question. Okay. Okay. Yeah. Okay. This is the recording. Good. So, all right. So let's try this. Maybe you can try all of these. Okay. State Newton's law of motion. Man, builder, cradle, stuff, awkward, blah blah blah. Okay, man, cradle, respectively. Okay. How about we try doing this? I think this thing takes you guys like what, 2 minutes? Okay. You have to stay all. I will stay all. Okay, maybe 3 minutes. One for each. Okay, 3 minutes. Okay. This takes around three. Okay, this takes around two. I think this takes around also two. This takes around five. Okay. So I'll give you guys until like how much is this? 3, 3, 6, 10, 15, 15 minutes. Okay. Num num 10. Then we will discuss this question for another 15 minutes and we can maybe end the class here. And these questions, there's some remaining questions I wanted to finish. Okay, there's some remaining questions here. I will give you guys on an exercise. I haven't given exercise since last week or so, right? Okay, I'll post both of them, but they have different deadlines. Okay, don't worry, they have different deadlines. One will be maybe this week, and the other one maybe like 5 days or 4 days after. Okay, tomorrow chutti, right? Okay, so maybe you can use tomorrow's time to start doing the questions. Okay, I'll have a go. I'll come back around 10 o'clock. Okay, we'll start discussing this. Hopefully, you guys have the answers by then. Resume the class. All right. Okay. So, state Newton's laws of motion. Okay, let's see. Okay, Newton's first law. Okay. Let's say rest motion, cause velocity, and that's the okay, this is good. An object expresses the rate of change in linear momentum. Force acts upon the object forward direction of change of momentum. Okay. The law for For action force, for action force, there
Oh,
is,
I had a stroke there. It's supposed to say for every action force.
yeah, I can tell. Every action force, there is an, she said equal, but you cut out the equal also. So she said equal reaction, force of opposite direction but equal magnitude. Oh, that's reaction force of opposite direction equal magnitude. Yeah, that's the important part. Okay then. Okay, this one. Okay, now let's go to the questions. Okay, all right, let's go to Tiny. Uh, okay. Remain at rest, objects in motion, or continue movement motion, constant
The
force.
acceleration, I got 8.33.
You got 8.33. Where? That's last answer. Acceleration I1. Okay. Oh, you wrote this as I1. This A, right? Uh, what was the answer again? 8.33. Okay. Okay, that was the answer. Okay, never mind. Okay. I only wrote one. You had to write all three. Remember they say, if you mention state Newton's laws of motion, plural, that means you had mentioned all three like Brian here. So one law actually is one. I know it's a bit annoying to write that, but it's only half a line. You've been huffling it since Form 4, Form 5. So it should come off quite easy from your tongue. Okay. Uh, yeah, I have gotten my warning message to come early. Oh, good. Okay, never mind, never mind. Don't worry about that. Okay, you should mention all three. So this I can only give you 1 mark. This actually is supposed to be 3 marks. Okay. But I only get 1 mark because I only mentioned one. It's okay.
Okay,
All right.
okay.
Let's go to the main questions. Okay. When they say laws of motion always apply, there's also a few other things you will learn later. Kirchhoff's law. Kirchhoff's law of electricity that will be later in Sem 2. There's actually two laws. One is what we call Kirchhoff's current law. Another one is called Kirchhoff's voltage law. His name is actually Kirchhoff. We call him Kirchhoff.
I
We not
cannot
call him.
hear you.
Oh, can I hear me? Okay.
Hello.
Can you hear me now? Let's see if phone. Yeah, should be okay. Oh, she left the call. Okay. Very polite. Okay. Oh yeah, she was having audio issues before. Never mind. We'll give you like 2 minutes to join back. So, okay. Alright. Never mind. Okay. Mass of the man and the cradle are 60 kilograms and 30 kilograms respectively. If he is pulling the rope with a force of 500 newtons, so it means this is 500, and this is also 500. Assuming it's a smooth pulley, right? Calculate the acceleration of the cradle and draw a free body diagram of the man. Okay. He is here. I see. Okay. Hello. Don't worry about the plus time, Brian. Sometimes it'll be plus, sometimes it'll be negative, plus minus, but usually it'll be a bit plus. I don't see the point of finishing exactly on time if you guys don't get any knowledge from it also, okay? Don't worry, it's okay. I'll try to end it now. I'll try to end it as soon as possible. So, okay, 500 down, 500 up. Okay. Okay. So, how
Hello.
do we? Yeah. Okay. Yes. Okay. BI. Oh, hello. I muted myself. Okay. Sorry. I was saying just now, Brian, to not worry about the classes. Sometimes be a bit class. Okay, reviews. B1. Okay. So how do we draw a free body diagram? Okay, free body diagrams like this. I prefer drawing stickman. Okay, stickman is nice. Stickman is easy to draw. Okay. one was attached here, another one here, it's holding it. Okay. Yeah, just think of that as the floor. Okay, just think of the floor. Okay. So there is a tension up. Okay, and there should be okay, m plus mg. Okay, there's a weight component, right? So it's a m plus mg. That's downward. Okay, and there is a acceleration upward. Okay, this will be the tension force. So the acceleration upward. Okay, if you're gonna use a TA
M
and
plus
S
mg.
up,
Cradle
M plus
and the
man, then
man.
yes, when you're using all of this, right? Please, if you're drawing a free body diagram, explain what P equals to, what A equals to, what M equals to, what a small m equals to. Okay, what the G also equals to. G maybe no need because G is universally known as gravity, right? Okay, but better to mention this stuff. Okay, so the first question will be something like this. Okay, this be up, this will also be up. Okay, there'll be two tensions. Because you're pulling, there's also tension here, there's a tension here, so that's be like 2T. Okay, minus what? Minus M plus mg equals to M plus ma. Okay,
Mm.
so that's 2 times by 500 up and down. Then 60 plus 30, that's 60, right? 60 and 30 g equals to, that is right here 90 g, 90 g. Oh, sorry, 90a, 90a, 90a. So end of the day, you get, I think, A equals to 1.30 ms negative 2. So did you both get this value? Let's see, you got something else.
I get 8.33.
8.33, so big, bit too big. Okay, I'll just logic out. Okay, if you get 8.33, that means you are the same speed as almost same speed as gravity. That means like he's pulling so fast, he's pulling at the same speed of gravity. Yeah? So sometimes logically also this one also okay. Okay, around 1 to 2 lah. 1 to 2 is okay. Sometimes physics still has to make sense. Physics still has to make sense. Okay. So if he's pulling 8.33 something from here, that is very close to gravity already. Okay. One is okay, still fine. 1.3 is still fine. You just one time he suddenly pull right, pulls very fast. Okay, that's still fine. Okay. That's okay. Okay, now let's go for question B. B2. First that the man exerts all
Actually, I've
the.
got a question.
Yes, hello.
If
Question is,
he is pulling the rope with a force of 500 newtons, wouldn't he be falling down?
wouldn't he be falling down?
One
No.
arrow is upwards, one is right.
Okay, both are upward. Okay, because there's a tension force here also. Okay, how to say? It's in equal form. Okay, the tension, there's one tension up here, and then there's also another tension up here. Okay, he's giving that tension. Okay, you can imagine it like tension goes both ways, right? Okay, you pull it up here also, the tension still acts on this side. Right? Let's say you have a hand here. Okay, this is your hand on one side of the rope. This is your hand on the other side of the rope. No matter how you pull here or here, there's a tension on acting on here, right? Okay, it will become tightened. So same for this logic also.
No, when he pulled the rope is going to go down. Then left side, the rope will go up, right?
Let's say go up, down side go down.
Go down.
Okay, let's say
So the tension opposite.
okay, let's say if he's just holding the rope. Okay, he's just holding a rope with force of 500. Okay, now like this side, right, he's just holding it. Like if you're holding the rope, let's say you're just holding it, hold your own weight, like you're just holding your own weight for now. Okay. Then you're providing a tension of 500 here, right?
Yes.
Just holding the rope. But when you pull down, the tension comes down because you're pulling it down. I think that's what the question is asking also. Because I have done this question before. Okay, what you said makes sense, lah. When you pull it down, shouldn't the tension go down? But then uh, the question wouldn't make sense because if atas 500, then here also 500, both also 500 negative, then this will get completely cut down. Then he won't be going anywhere. Okay, so there's like two forces. Like one is the constant of him pulling it up. He's pulling it up, and also him just holding on to it. Just holding on to it itself is a force itself. Right? Okay, because okay, let's say you cancel both of these out. That means that he'll be start falling down. What? He'll just start falling down, right? Because m then they just become m plus mg equals to m plus ma. Then he's just falling down, right? Would it make sense? Because if you say this is only 500, but where does this 500 come from? This 500 has to come from somewhere. What? And if this 500 comes from here, then if you see this is negative, then both of these will get cancelled or what? Then doesn't exist, right? The net of this 500 won't exist. Okay, they're confused. I'm so sorry. They confuse you. Okay. I hope. Okay. So let's go to B. Let's go to B. How about we go to B first and see goes on. Too weak to lift. What? Too weak to lift. My guy too weak to lift. Okay, that's a bit. Okay, B2. Okay, I do these people messaging. Okay, never mind. Okay, so there's a reaction force with the floor, and then there's a tension on the rope, right? Okay, so should be here. Okay, I'm trying to basic answers first. Okay, never mind. Let's go here. Okay, so question two. Question two is what? Question two. Force that the man exerts on the floor. Okay, force on the man exerts on the floor. Okay, then there should okay. So naturally, you always have the normal force. Okay, we call this normal force as R. Reaction force or normal force on R. So this is the trigger, right? Okay. So there'll be a tension. Okay, that he's holding up, having a tension here. It's 500. Okay, he's obviously accelerating upward. So it's A. Okay, and then he has his own mg. Okay, so that will be R up plus the tension. Okay, R is anything that's against gravity. So this will be R. Okay, R plus T. Okay, equals to you can say sorry, minus mg. Okay, minus mg because mg is going down equals to the resultant acceleration, resultant force. Okay, so we know this is okay, we know the tension is 500, and we know mg is 60.981. Okay, that equals to 60 point. We know just now about the acceleration, and it's by 1.3. Okay, theta, you calculate all this, you get R equals to roughly 1.66.6 newtons. Okay, so that's roughly R. You guys get the answer? No, you got 588.6. You got 588.6. Both got 588.6. Oh, is it because both of you guys did 500? Okay, I'll look into both of your answers later. Okay, I'll see what's going on later. T2 minus T1 equals to T. Okay, I'll look into these answers later. Both of you got the same answers or more. Okay, I'll have a look later on this too. Because this is the answer I have, and I also tried it. Remember, also I got this. Okay. Okay, now mine. Try. Okay, for the sake of the class, I'll finish this first, then I'll look through this one. Okay, a vertical force on axle of the smooth pulley. Okay, this thing. So the vertical force acted on the smooth pulley is this thing. Okay, so that's how do we calculate that? Okay, so you have to calculate that. Okay, that's pretty simple. We have a pulley system here. Okay, in this case, the tension will be downward. Okay, tension will be downward, and there's a force upward here. Plus, will be T here, also T here. Okay, so that'll be just F equals to 2T. So just like this 1000 meters, straightforward. Okay. Okay, now finally our last question. Okay, the last question says force on the man, the force that the man exerts on the floor when the rope breaks suddenly. Okay, the rope breaks. Okay, we don't know which part of the rope breaks, but it just breaks. Okay, so we say if it breaks. Okay, so that means that he is falling, right? Okay, what is the acceleration of falling? Acceleration of falling is gravity. Okay, A equals to G. Okay, that means that mg minus r equals to ma. Okay, and we know that mg minus r. Okay, now we know his resultant is falling, free falling, right? That means that it's also mg. So in that case, it means that r equals to mg minus mg. 0. There is no force acting on it. Okay, technically.
You actually got that right now.
You got it right? Yep.
I actually got that right out of
Yeah.
your guessing.
It's the man with flip flops. 0 newtons. Okay, good job. Good job. Okay, that's a good job. Did you attempt the last question, Thalini? No. Oh, okay, never mind. Okay, that's a good job. Guessing, okay, right, okay. Okay, so the force that man exerts on the floor and yeah, okay, the force that man exerts. Okay, there's no force. He's not exerting anything. Okay, because for you to exert something, something has to go here, something has to come up here. Up, yes, come up here also. Both of you guys are falling down at the same rate. Okay, the man also falling down, the floor also falling down. So everything just falling down. So the net is 0. Okay, for this one you don't even need what do you call this? You don't even need any working. You just put I think 0 lah. Okay, I think should be enough. But if you put working also is good because I think this is around 1 mark, still 1 mark. It takes some time to think about it. It's one of the easier answers, but it takes time to think a lot. The force will be 0 meters. Okay, so we finished one essay question. Okay, let's see what our progress is today. So finished 1, 2, 3 objectives. Then we did one structure and one essay. Okay, in 2 hours. Okay, pace is a bit slow, but it's alright. We'll try to find some time to. Okay, as per usual, I'll upload the recordings of the class maybe by tonight because apparently I have to go out. My HOD is calling me. My, yeah.